Looking at equivalent ratio, what does this mean? This means that we are looking at two or more ratios or fractions that are equivalent by a scale factor. Take note that this scale factor must be common, and this here will enable us to determine what the equivalent ratios are. Now, in terms of ratio, looking at the setup, we have an example where we have 1 to 2, and we want to check whether this here is equal or equivalent to the ratio, let's say 4 to 8. And in order to determine the equivalence, what we do is we can go in two directions. One is either we check going from 1 to 2, which is determining what the scale factor is going to be, which means that we can only use the operation multiplication or division to determine whether this is true. And this here shows that going from 1 to 2, we multiply by 2, which means that let's see whether going from 4 to 8, we also multiply by 2. In this case, yes, if we multiply 4 by 2, we get 8. Therefore, yes, these two ratios are equivalent to each other or are equal to each other because they have the same scale factor, which is times 2. Another setup is going from 1 to 4, and let's see whether the same scale factor will get us from 2 to 8. In this case, going from 1 to 4, we multiply by 4. And this here, let's see whether going from 2 to 8, we also multiply by 4. In this case, yes, we all multiply our 2 by 4 to get 8. Therefore, that means that yes, as well, these two ratios are equal to each other. Now, another setup is looking at the fraction format. And using the fraction format, let's say we have 4 over 5, and we want to see whether this here is equal to the fraction, let's say 40 over 50. And this here, looking at this, yes, indeed, there are ratios. 4 over 5 is the same thing as 4 to 5. And we are also determining whether it is equal to 40 over 50, which is also rewritten in ratio form to be 40 to 50. And so we are going to use our analysis to determine whether these two fractions or ratios are equivalent to each other. To accomplish this, now in here we can see is that we cannot really determine the scale factor that is a whole number going from 4 to 5. I'm doing the same thing as well, going from 40 to 50. So this here will not be an ideal way to address or determine the value. However, if we go across going from 4 to 40, this means that we have a scale factor, which means that we multiply by 10, and we want to see whether this is going to be applicable from 5 to 50. And in this case, yes, we multiply our 5 by 10 to get 50. Therefore, because this scale factor is the same as this scale factor here, this here is true. Likewise, using this setup here, going from 4 to 40, we multiply by what? 10, and as well we multiply our 5 by 10 to get 50. So yes, as well, this setup works not only in terms of using the fraction format, but also using the ratio format. In here we have examples where you have to pick the ratios that are equal to each other. And this here for A, we are looking at these three ratios, and we're going to check the ones that are equal to each other. To do this, all we do is figure out how to go from the first number to the second number in terms of what is the scale factor. And in this case here, yes, going from 9 to 3, we're going to divide by one number. Scale factor is 3. And let's see whether going from 12 to 4 for the next question here gets us the same scale factor. In this case here, 12 to 4 we are reducing, which means we're going to divide by what? 3 as well. And so this seems that these two ratios here, they have the same scale factors, which means that they are equivalent ratios. Let's see the last one here, going from 6 to 3. In this case here, we're going to divide but by 2. So that means 6 to 3 is not an equivalent ratio to 12 to 4 and 9 to 3. Instead here, 9 to 3 and 12 to 4 are equivalent ratios. So those are correct. Now for B, we have a different case scenario where we're going from 7 to 8, and in here we have a scale factor that is not addition but multiplication. Whichever number you figure that it to be is not a whole number in this case. So let's see the next one here. We're going from 2 to 10. In this case here, we're going to be doing what? We're going to be multiplying, because it's increasing, by what? 5. So that means we're going to multiply our 2 by 5 to get 10. And let's see, going from 1 to 5. In this case here, we are also increasing, which means that we have to multiply our 1 by 5 to get 5. That is awesome. And finally, let's see, going from 3 to 15. We're going as well increasing. That means we're going to multiply our 3 by what scale factor? 5. So in this case here, we have 3 of the 4 ratios that have the same scale factors, which means that 2 to 10, 1 to 5, and 3 to 15 are equivalent ratios. So this is how we're able to analyze ratios based on their equivalencies by determining whether they have the same scale factors. I hope you found this really informative. See you on the next one, and believe in yourself.